Hello friends, welcome to our channel. I hope you are all in a very good health and doing well with your studies. Thank you for joining me. Today we are going to discuss about refraction of light through a prism. So let us start. So let us first discuss about what is a prism. There are many types of prism, but we are going to discuss about only one type, that is triangular prism. So let us first draw a triangular prism. This is how it looks like. So we can see that it is made up of glass or plastic. So made up of glass or plastic, which is transparent. which has five faces. One, two, three, four, and five. This is a 3D object. Okay. So this is a 3D object. It has five faces. Three rectangular faces and two triangular faces. Triangular faces are parallel to each other. And rectangular faces are perpendicular to the triangular edges to the perpendicular to the edges of the triangle. Rectangular faces are perpendicular to the edges of the triangle. One thing I would like to mention, which is not required in this case, but still I am going to mention it. The surface area, this will come in use in mathematics. So the surface area of a triangular prism is equal to base into height of the triangle plus perimeter of the triangle into this length. Okay, let us assume this is L. Okay, so this is the formula. Okay, the surface area of a triangular prism is base into height of the triangle plus perimeter of the triangle into length, and the volume of the prism is equal to area of the base into length. If we consider this is the base, okay, and this is height h, then we can say half into base into height. This is area of the base. Two slant faces, that means this face, this surface, the front surface, this is a slant surface we can see, and the surface and the slant surface behind. That means okay, these two slant surfaces, the front slant surface and the back slant surface, these two surfaces are called, okay, these two surfaces are called, this is the first surface and this is the second surface. These two surfaces are called refracting surfaces. Okay, these are refracting surfaces. So we have discussed about two triangular surfaces and two slant surfaces. And the fifth surface, okay, this surface is also a rectangular surface. This surface is generally made rough. Okay, friends, let us do one thing. Okay, let us write it area of the triangle. Okay, we are not using the term base. Okay, area of the triangle into length. So we can see that the volume of a triangular prism is area of the triangle into length. Okay, in mathematics, if we consider a triangular prism, then these two triangles are considered as bases. Okay, so in mathematics, the triangular surfaces are called bases. Okay, but in physics, the lower surface is called the base in case of a refracting prism. Okay, so in this case, we are not using this term. So we can write triangular surfaces of the prism. We are not using the term bases. In case of mathematics, we take it as bases. Okay, but in physics, when we think about a refracting prism, the lower surface, which is the rough surface, is called the base. Okay, that means the lower surface is the base. Okay, this angle, that means the angle between two lateral surfaces or slant surfaces, is called angle of the prism. Okay, so this is angle of prism. Okay, and the intersection of the two slant surfaces, okay, the straight line where the two lateral surfaces intersect each other, is called the refracting edge. This is our refracting edge. Okay, now let us consider and one more thing, that is, if we cut the prism perpendicularly. Okay, if we cut the prism perpendicularly, we get a triangular cross section. That means, okay, we get a triangular cross section. Now we can take a light ray, a monochromatic ray of light. Okay, let us assume this is air and this is glass. So a monochromatic light ray is coming and striking the prism like this. The ray should go in this direction when the prism is absent, but the prism will bend. Okay, let us consider a perpendicular at the point of incidence, a normal at the point of incidence. Okay, so the when the light ray travels from a rarer to a denser medium, the light ray bends towards the perpendicular. So the light ray will go like this, and when it strikes the second surface of the prism, it should go like this. Okay, it should go like this, but when the light ray is passing from a denser to rarer medium, let us draw a perpendicular at the point of incidence. So when it travels from a rarer to a denser medium, a denser to a rarer medium, it will move away from the normal. So it will go something like this. This is called the incident ray. This is our refracted ray, and this is our emergent ray. Now, if we apply the principle of reversibility of path of light, that means we are sending light from this point. Okay, now if we do the exact opposite thing, that means we are sending the light this way, that means we are now sending it this way. So the light ray will get refracted at this surface. Okay, let us call it surface 1, let us call it surface 2. So when we send light ray from the opposite direction, it will first get refracted by the second surface, and after that it will follow the same path inside the prism, and it will strike the first surface and it will again get refracted, so it will follow the same path. Okay, so when we consider sending the light ray from the opposite direction, okay, the light ray will go like this, and after refraction, okay, we the light ray is going like this, and after refraction it bends towards the normal. Okay, if we remove the prism, the light ray should go like this. Okay, but as we have placed a prism in its path, so it will bend towards the normal and it will follow this path, and after another refraction it will follow this path. Okay, so now why we are applying principle of reversibility of path of light, you will know, you will understand it very soon. Okay, so what we are doing, okay, let me summarize it. Okay, first we are sending the light ray in this direction. After getting refracted, it bends towards the normal and it strikes the second surface, and again it is getting refracted and it is moving away from the normal. Okay, this is the first thing we are doing. Now if we consider, if we think that we are going to send the light ray from the opposite direction. Okay, so according to the principle of reversibility of path of light, if we send a light ray from this point, okay, it will trace the same path as before. Okay, now we have a clear understanding of it. Now let us um, write that this point is let us call the prism ABC, and let us call this point D. Okay, and let us call this point E. Okay, this is our angle of incidence I1 when we are sending the light in the forward direction. Okay, this is our angle of incidence, and this is our angle of refraction, and this is our angle of deviation delta 1. Okay, I hope it is visible and comprehensible. Now let us send the light from the opposite direction. Okay, if we send the light from the opposite direction, this is our angle of incidence. Okay, E is point of incidence. Okay, and this is our angle of incidence. Let us call this angle I2, and this is our angle of refraction, and this is angle of deviation, which is delta 2. Okay, angle I2 is can also be called, okay, angle I2 can also be called angle of emergence. If we send the light from source 1 and let us call it source 2, okay, so if we send it from source 1, this angle can also be called angle of emergence. Now let us call this point F, and if we extend these perpendiculars or normal, if we extend these two perpendiculars, they will intersect at a point. This point, let us call this point G. Okay, this is our angle of prism, angle A. Now the total deviation, okay, I hope the diagram is clear to you. I hope it is visible. I hope the diagram is visible. Now we know, now if we calculate the total deviation produced by the prism, which is equal to delta 1 plus delta 2, total deviation delta is equal to delta 1 plus delta 2. If we show the total deviation in the diagram, this is this angle. The ray, in absence of this prism, the ray should go like this. Okay, the ray should go like this. But when we put this prism, the ray is going like this. So the angle between the path that the ray should be following and the path it is actually following, this angle is called angle of deviation. Okay, so this is our angle of deviation, delta. Okay, so we can see that in this triangle, if DE, in this triangle, this angle is equal to the sum of these two angles. Why? We know this property of a triangle. The external angle will be the sum of internal opposite angles. So delta is equal to delta 1 plus delta 2. Now we can write, in place of delta 1, okay, in place of delta 1 we can write okay, see one thing, this angle and the total angle, okay, these are vertically opposite angles. See clearly, okay, this angle I1 and the total angle, that means R1 plus delta 1. Okay, these are two straight lines. This is one straight line and this is the second straight line. So okay, I hope you are able to understand it. This is our first straight line, this is our first straight line, and this is our second straight line. Okay, okay, this is our second straight line, this is our first straight line. So these are vertically opposite angles. Okay, these are vertically opposite angles, so we can write that vertically opposite angles are equal. Okay, this is our first straight line, this is our second straight line. Okay, so I1 and the total angle, that means R1 plus delta 1, these are vertically opposite angles. So I1 should be equal to R1 plus delta 1. So delta 1 is equal to, we can write I1 minus R1. So this is what we are getting. Now similarly, delta 2 is equal to I2 minus R2. So if we add these two equations, we are getting total deviation, that means delta equal to delta 1 plus delta 2, that means I1 minus R1 plus I2 minus R2. So I1 plus I2, we are taking minus common, so within bracket R1 plus R2. Okay, so this is what we are getting. This is the value of delta. Now if we um, think about it, it is difficult to measure R1 and R2 because it is inside the prism. So we need to replace R1 and R2, R1 plus R2 by something, or you can say we are going to write delta in such a way which will make it easier for us to calculate the value of it. So we can write that if we think about this quadrilateral ADGE, okay, if we think about this quadrilateral in quadrilateral ADGE, we can write the sum of all angles equal to 360 degree. Sum of all angles equal to 360 degree, or we can write angle A plus angle ADG plus angle DGE plus angle GEA. GEA equal to 360 degree. But these are normals. These are perpendicular. So this angle is 90 degree. ADG and GEA. These two angles are 90 degree each. So we can write angle A plus 90 degree plus 90 degree, that means 180 degree, plus DGE equal to 360 degree, or angle A, if we take 180 to the right side, so 360 minus 180, it will give us 180 degree. So angle A plus angle DGE. Now DGE, if we think about this angle, DGE, if we think about this angle, okay, in this triangle, that means if you see very carefully, in triangle DGE, in triangle DGE, the sum of all angles equal to 180 degree because it is a triangle. So angle G will be 180 minus R1 plus R2. Okay, I hope it is clear. This angle will be 180 degree minus R1 plus R2. Total 180 degree. So if we subtract these two angles from 180 degree, we are getting G. So G is equal to DGE is equal to angle DGE. Okay, I hope it is visible. Angle DGE is equal to 180 minus R1 plus R2. So now we are putting the value of it in place of DGE. So in place of DGE, we can write 180 degree minus R1 plus R2 equal to 180 degree. So we can cancel 180 degree, 180 degree. So angle A is equal to R1 plus R2. So now we can write delta. Okay, in this expression we can replace the value of, we can substitute the value of R1 plus R2. So this is, that means delta equal to, therefore delta equal to I1 plus I2 minus angle A, or we can write delta plus angle A is equal to I1 plus I2. So this is what we are getting. For getting a minimum deviation, I1 should be equal to I2. Okay, let us write it I. Okay, so we can now write, so this expression becomes delta minimum is equal to plus A is equal to 2I. Okay, or we can write delta min is equal to 2I minus A. This is another form. So when we now, I hope it is clear to you. I hope you are able to understand what I have discussed today. If you have any problem or any doubt, you can leave that in the comment section. I shall definitely answer them. That's all for today. Tomorrow we shall come with another video. Thank you.